just for the record. So here we go. First section, of course, we're going to talk about anything and everything to do with angle measurements. We're going to talk about degree measurements. You know how degrees work. How many degrees are in a full circle? 360. And then we're also going to talk about the relationship to radians. You've worked with radians. You know how to put your mode and your calculator on radians, but we want to make sure we understand how to convert between the two. So we're doing everything you can do with an angle today. We're going to draw angles. We're going to figure out what quadrant they're in. We're going to talk about complementary angles, geometry, supplementary angles, degrees to radians, radian degrees, anything and everything with an angle. Okay, let's get into the drawing part of that. So, a couple things you have to fill in. First one's already all set for your notes there. The vertex is always on the origin, every single time. The initial side is on the positive x-axis. So there's the first blank you have to fill in on your notes. So, here's your initial side. You can see in the very lovely picture. Now, depending on your angle measurement, if it's positive, your terminal side is going to rotate counterclockwise, or I just kind of think of it as up. You're rotating up, of course, so that's what this red mark is showing you. And if you have a negative angle, it would rotate clockwise or down. So again, the next thing we're going to talk about, if you have a full circle, you just told, oh boy, that's a bad circle, but if you had a full circle, you have 360 degrees, of course. Now, there is a geometry connection here. This is going to be fun, I can't wait. What also in geometry do we refer to the outside edge of a circle as? Yeah, you seeing it back there? Circumference, circumference. Do you remember what the formula is to calculate the circumference? Something with pi. Pi r squared is area. 2 pi r. 2 pi r is circumference. So, let's click it. So when we talk about radian measurement, because I don't want you to just like memorize how to mark it, we want to know the relationship of it. So, of course, it talks about what radian is, it intercepts an arc, blah, 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 you're going to see it here. So you need the circumference. You could just put C equals is fine, of course. The formula we just said was 2 pi r. You got to know it, hopefully. Now, we are going to be on what we call the unit circle. Unit circle is this little fancy circle that has a radius of 1. So when I talk about one full revolution, which of course is our normal 360 degrees, it is also 2 pi times the radius. It's 2 pi radians. So this is why. This is where it comes from. 2 pi, I know you know one full circle from last year is 2 pi, but the reason is it's really the circumference of the circle. So this, of course, is the same as 360 degrees. Just depending on if you're in radians versus degrees. Now, I saved you some room here on purpose. So we're going to draw some kind of detailed pictures here to draw our circles and to figure out the quadrants the angles are in. You don't have to redraw these circles then for the notes or examples or the homework or anything else. We're going to use the pictures up here for everything. So I'm going to draw you 2 pictures. I'm going to draw you one for if the angles are positive, and we're going to do one for negatives. We're going to label everything. These are going to be the most amazing pictures you've ever seen. And you can just use them then for everything. So I'm just positive, negative. Okay. So, as always, first question we should ask, because they're going to ask you what quadrants some of the angles are in. Do you remember how to label the quadrants? Okay, just if you need it, write them on there, but it looks like we have that. Now, of course, when you draw your angles, just like it said, the vertex is on the origin, initial side is on the positive x. So you're starting right there at 0 degrees. Now, I'm doing my positive one. To label, because you are going to have to label the axes on any quiz or test. Well, there's 4 quadrants, so I'm just doing a little mental math here. What's 360 divided by 4? 90. So we're going to add 90. I'm going to add 90. I'm going to add 90, and I'm going to add 90 and get back to the full circle. Now, of course, you might have radians. I'm going to do the radians in purple. So you start at 0. Now, little mental math here, but I'm actually going to write this one out, so I guess not so mental. Of course, 360 we divided by 40 at the 90. You would do the same thing. If I divide that by 4, well, what's 2 over 4? 1/2. That is why you're scaling or counting every time by 1/2 pi. Now, 1/2 plus 1/2, 1. I just put the 1 in front. 1 plus 1/2, 1.5. You can use 1.5, but commonly we use 3 pi over 2, just because it takes up a little less space. 1.5 plus 1/2, 2. Just for the record. Now, this is going to be super, I'm not going to put the quadrants on here, we already have them. So of course negative just means vertex, same initial, but this time you would be rotating clockwise or down. So you're going to subtract 90. Subtract 90. Subtract another 90, and then our full circle. It is a tiny negative symbol there in front of 360. I'm also going to throw the radians on us. Like I said, I'm going to spend some time to draw some very detailed pictures here, but we don't have to redraw them again today. We can just use them for the examples. You can use them for the homework. So of radians, of course, we'd be at 0. I'm going to subtract 1/2 pi. Subtract another 1/2. Subtract another 1/2. Subtract another 1/2. I'm going to put one more thing on. You're probably like, no. Sometimes they get fancy on the radians, okay, and they'll give you the radians value without pi in it. Because remember, pi is just a decimal. What's pi approximately? 3.14. So they might just give you like 3.14. So you kind of have to need to know some of these decimals, which I'm going to pop on here in a second. Now, pi over 2, that one I can do in my head. I'm like 3.14 divided by 2. I can do 2 pi in my head. What's 2 times 3.14? 6.28. I'm not going to lie to you. I do have to type 3 pi over 2 in my calculator. That one I can't do in my head. It's about 4.71. So in case they just give you the decimal forms, they don't give you the pi on it, we can still figure out where to mark these angles. Now, other fun filled, because you know I love geometry. How do they actually calculate pi? Why is it 3.14? Okay, so I hear they felt like it, the computer tells me so. Do we have any sort of geometry answer? Okay, so I think it has to do with circles, If you take the circumference of any size circle, the clock, something bigger, smaller, I don't care, and divide it by the diameter. If you divide the circumference by the diameter, it's 3.14, it's pi, every single time, regardless of the circle. Hey, we should know that. Okay.
I didn't know that.
Here we go. Now, yours is in front of you. I'm going to have to click back and forth, but that's no big deal. Determine the quadrant on which side it lies in. Okay, so look back in your picture. If it helps you fractions, you got to be a little good at fractions today. 1/5 pi, positive. So I'm looking at the first graph. So I'm like, ooh, 1/5. Oh yeah, 1/5 is between 0 and 1/2. I'm just good with fractions. 1/5 is about 0.2, half's 0.5. So it's going to be in quadrant 1. If it helps you, 7/5. Sometimes I think it's easier to make these a mixed numbers. Last hour asked me to review how to make it a mixed number. How do you make this a mixed number? 5 goes into 7 once, and there's 2 remaining. Okay, back to the picture. So I'm looking for where would 1 2/5 pi end up? Quadrant. So it's going to be past 1. The question is it between 1 and 1.5, or is it between 1.5 and 2? It's 3. It's between 1 and 1.5. So 3. All right. Now we've got 3.5. So decimal. That's still radians. That's why I put all those decimals on 3.5. Well, it's a little past 3.14, right? So we're going to end up in quadrant 3. And then 2.25. 2.25, it's going to be between 1.57 and 3.14, so 2. So that's why it made you such detailed pictures. You can just use them now. Same for the homework. Hey, one page down, 3 to go. Okay, sketch it. Now, focus, my friends. Clearly, I can't, force you to get crazy with all the pretty picture perfect labeling on your homework, although I would appreciate that. On any quiz or test, it's going to tell you when you have to draw these to label the axes, meaning, clearly we're in radians, so 0, pi over 2. It's going to ask you to label these. Can I force you on the homework? No, but it is going to ask on any quiz or test when you have to draw an angle. Okay, as always, vertex on the origin, initial side. We have to be a little good with fractions. What quadrant is 5/4 or 1 1/4 going to land you in? 3. It's going to be a little past 1. Now, I'm not going to get like a protractor and measure and get crazy. I'm just, okay, that's 1 pi, 1 1/4. Yeah, sure. So from here and around, I'm just going to label. We covered 5 pi over 4. All right, negative 2/3 pi. Now again, same spiel. It's going to ask you on any quiz or test to label the axes. So I'm going to label every time today. Negative, we're going to rotate clockwise or down. So I'm going to subtract half pi. Subtract another half, and a full circle. As always, vertex on the origin, initial side. We're rotating clockwise or down. We have to be good with fractions. Where does negative 2/3 going to fall? Between negative 1/2 and negative 1. Negative 2/3 is close to negative 1. Now, do I care if you do my very dramatic labeling here that that's my negative 2/3 pi? No, I'm not going to get too upset about that, but axes, like I said, will need to be labeled on a quiz or test. All right, 7 pi. Oh boy, okay. All right, I got it. And of course, this is the most, let's be honest, this is the most time-consuming part of the homework. The rest of it's not bad at all. Positive, so I'm rotating clockwise or up, scaling by 1/2 pi. And this is a fun one to draw. Now, clearly, 7 pi is more than 2 pi. It's more than 1 revolution. In fact, I'm going to have to make how many complete revolutions? 3. That'll put you at 6 pi, and then I'm going to have to go 6 1/2, 7. So let me draw it first to show you, just to make sure you know how to draw it. So, of course, I'm starting here on my initial side. So there's 2 pi, 4 pi, 6 pi, 6 1/2, 7. A little trippy. Now, I find that obnoxious to draw, of course, my lack of artistic skills, but didn't I just end up at the same pi as the same place as pi? So this is going to lead us to the next thing we're going to talk about, but I'm going to stop for a second just so you have the visual in front of you. We're going to start talking about coterminal angles. How you can move different routes on the graph and end up at the same spot. If I just told you graph pi, bam, you're right there. So you can add or subtract 2 pi off your angle to make your life a little easier, which is what we're going to do. Because if I took 2 pi off, I'm at 5. Another 2, I'm at 3. Another 2, I'm at 1. So that's the same spot. All right, please make sure, of course, we have our earbuds out of our ears and we're focused on math, people. Okay, negative. But notice you don't have a pi on it. So when I label, love the trains coming through. When I label, I gotta go one more. When I label, I'm gonna use these decimals, okay? So pi over 2 is about 1.57, so I'm gonna use that. I'm gonna use the decimals when I do this guy. Oh, one more, come on. So I'm gonna do negative 1.57, that's my negative pi over 2. Negative pi, and then of course 3 pi over 2, that's the one I have to type in my calculator. Sometimes that's an easy one. And then a full circle. I was going to put negative 2 pi, how about negative 6.28? Just out of habit. Okay, vertex, initial. So negative 3, of course, is going to be pretty close to this negative 3.14. So let's just kind of, close enough. Got it. So any questions I can answer for you on getting the graphs drawn. Again, I know it's obnoxious to label. That's the most time-consuming part of the homework. The rest is not going to be so bad at all. Because next up, we're going to talk about these coterminal angles. Now that's what we talked about with the 7 pi. Graphing 7 pi was kind of obnoxious just to land at pi. So of course, coterminal angles have the same initial side, same terminal side. So you're landing in the same location, you're just maybe taking a different route to get to it. And of course, we can, like that 7 pi, I could have reduced it by 2 pi multiple times. I could have taken off 2 pi a handful of times to end up just at pi. So, determine 2 coterminal angles, one positive, one negative. Give the answers in radians. Okay, all right. So, start with my angle. I'm going to add a complete revolution. Now, if you are not great with fractions, which we should be able to do 1/9 plus 2 in our heads, I hope. If not, you could use your calculator and do the 1/9 plus 2, and you put the pi on. Just do the fraction work. If you do 1/9 plus 2, your calculator is going to give you 19/9, which is totally fine. You could do 2 1/9. You could do the 19/9. Doesn't matter to me. Again, hopefully we don't have to use our calculators. Okay, negative. So I'm going to subtract 2 pi. But let's work smarter here, because if I'm going to subtract fractions, of course I know I need a common denominator. So I'm just mental mathing it here. I'm like, oh, okay. I'm like, 2 is the same as 18/9. I'm like, 1 minus 18, negative 17/9. And again, if you're not great with fractions in your calculator, do 1/9 minus 8 minus 2, and then you put the pi on. But I hope we can do the fractions. All right, let's add 2 pi. Now again, I'm going to go old school and common denominator it. 2 is the same as 6/3. 4/3, 6/3, 10/3. And then of course we're going to subtract. So I already did the common denominator part here in the blue. I'm just going to use it. I'm just subtracting, of course. 6/3 is 2. So 4 minus 6, got it. And again, you could always type in your calculator 4/3 minus 2, and then you put the pi on. So any questions on the calculator, any of that? Little fractions, we love fractions. Okay, now we're going to work, it's a little easier, I think, in degrees. Determine the quadrant 121 degrees is in. So again, if you flip back to the pictures, 121 positive, it's going to be in between 90 and 180, so it's in quadrant 2. Negative 22, let's look at the pictures, get to it here. So the far graph, negative 22, well, that's between 0 and negative 90, so that would lie in quadrant 4. That's why I got carried away with the detailed pictures. You can just use them, of course, from here on out. Hey, 2 pages done, 2 to go. Okay, sketch each angle in standard position. Okay, got it. Now again, I can't force you to get dramatic on the homework, but any quiz or test, it will ask you to label these. Remember, we're scaling in degrees by 90, so I'm adding 90, 90 plus 90, plus 90, plus another 90. Initial side. Well, because you know I love geometry, 180 degrees back in the day in geometry, do you remember the fancy name for it? Starts with an S.
Supplementary angle.
It's a straight angle, because it makes a straight line. Who knew geometry would come back to haunt ya? Isn't that great? It's so great. Also, just because you know I love my vocabulary, we are going to do a lot with evaluating like sine, cos, and tan of 180, 90, 270, etc. Those are called, when you're on the axis, quadrantal angles. Have you heard of that, quadrantal? Get ready, it'll be fun, good stuff. All right, negative 450. Oh boy. I don't love that it's over 360, but I'm going to deal with it. So of course, Negative, you're rotating clockwise or down, you're subtracting 90. Now, if I had to do like sine or cos or tan of this, which is what we're working our way up to, let's get serious. I wouldn't actually mark out negative 450. I would add what to that?
360.
360 to make my life easier, okay? Negative 450 plus 360 is negative 90, so we're going to end up down here. I am going to draw it, though, the negative 450, because that's what they want me to do. So I'm going to need one full revolution and then another 90 more. And that is one of our quadrantal angles. Since you end up on the axis, that's as wild as it gets. Gotta love it. Any questions on that? All right, easy peasy here. Determine the coterminal angles, one positive, one negative. So we're in degrees, so we are not adding 2 pi, we're gonna add 360 or subtract 360 to these. Now, you can do this all in your calculator. Of course, I'm gonna write work for the love of math. We're gonna add 360. What's 36 plus 360? 396. And then it wants a negative answer, so now I'm going to subtract 360. And again, you don't have to write out the work on the homework, you can just give me the answers. What's 36 minus 360? Negative what? Yeah. Now again, just recognize what is significant about this. If I made you draw 36 degrees, 396 and negative 324, you land at the same spot for all three of them. It's just different routes to get to it. All right, negative 45. So let's add 360. What do you got for that one? 3 what? Got it. And then I'm going to subtract 360. So besides having to draw the actual angles, the rest of it's easy. Adding, subtracting 360, adding, subtracting 2 pi, it's not a lot of work on these, okay? Now you might be like, why is she making us do another? This is so easy. And it is, but I can't say as I want to add 360 again right away, because isn't that going to put you at a pretty big, large number? And I know I got to get down to a negative. So I'm going to subtract 360, which is 380. So I could circle that as one of my positive answers. Now, here's a little glitch though. If I take 360 off of that again, you're at what? Which is also still positive. Every year, I swear, I'll have somebody give me on a quiz if I ask for a positive, negative, 380 and 20. I'm like, wait, I need a negative. So make sure you subtract enough to get you down to a negative. Now, for your positive answer, does it matter if you give the 380 or the 20? Does it matter? No, I don't care. I'll take either of them, obviously. You'll end up at the same location. Just make sure you subtract off enough to get to a negative, because we're going to tell you. Any questions on that? Miranda?
So can one of the answers be 740 plus 360?
Sure, you could give me that. Which is, I don't know, what is that, 1,000, 1,100? Yeah, just seems big to me. Okay. So now, of course, we're converting degrees to radians, radians to degrees. Now, this is all on your sheet, but hang on a sec. I gotta, you know I love the why. I'm gonna back it up to the beginning. Comes to this right here. Circumference of a circle is 360 degrees. But of course, can you reduce these each by 2? Yeah, pi 180. That is why the conversions, get to it here, are what they are. Because they're really doing 2 pi over 360. But of course, that's the reduced form of it, okay? So it's still that relationship, 360 degrees is the same as 2 pi. So if you're going to convert degrees to radians, pi over 180, radians to degrees, 180 over pi. I couldn't help myself. Here, let's get back to it. So much fun in math. Okay. Express the angle in radian, multiply pi, don't use your calculator. Okay, well that's kind of sketchy. So we're going to, of course, multiply all of these by pi over 180. I'm going to set them. I'm scared to ask what's happening. All right, so let's talk about the calculator note on this. It says don't use your calculator. You might need your calculator to help with the fraction work. Calculator, no calculator means just don't use the pi button. It doesn't want a decimal answer. But if you need your calculator to reduce this, which you probably would, you can. What's 315 over 180 simplified down to? 7/4, yeah. And I'm going to put the pi on. So it just doesn't want you hitting the pi button and giving a decimal. That's why it says no calculator, but if you need it for the fractions, hey, do it. Hopefully we don't for this one, because 60 goes into both of those. 60 goes into here, 2, 3, 2 pi over 3. All right, same thing. Probably want your calculator to reduce that. What's negative 144 over 180? Negative.
Negative 4 over 5.
Got it. So any questions on punching those in? See, light work, light work. The biggest, most obnoxious is the drawing the angles. All right, let's do the opposite now. So we're in radians, we're going to convert to degrees. So 180 over pi. Okay, so the pi's of course cancel. You might need your calculator, I don't know, maybe not, for negative 4 times 180. What do you got?
Negative 45 degrees.
What's negative 4 times 180?
Oh.
Negative 720. Make sure you put the degree symbol on. Okay, let's talk about that for a second. That is a nitpicky detail. If you don't have the degree symbol on it, you're telling me you're in what form? Radians. So you do need to be conscientious of that. Of course, the pi's cancel here. 60 goes into 180 3 times. I need a calculator. What's negative 15 times 3? Yeah. Calculator. Got it. Any questions on that? All right, page 3 done. This whole page is calculator work, this last page. Convert the angle from degrees to radians. So pi over 180 again. Now, it's more of the same, but notice it says to use your calculator and round to 3 decimals. So now you are using the pi button on your calculator. So multiply these together, 83.7 times the pi button, and then divide it by 180. And you are rounding, it says, to 3 decimal places. See what you got. What do we got? 81 point. Oh wait, I'm looking at the wrong one. Looking at the wrong one because 1 point. I freaked you out, didn't I?
I was like,
1 point. Sorry, my bad. Oh man, that's a sloppy four. I didn't even realize what I was saying. 1.461. There we go. Sorry. All right, what do you got for this one? Negative.
1.46.
Negative point. 812. Any questions on your calculators? All right, more calculator work, just going the opposite now. Radians, 2 degrees. So you're doing your 180 over pi. Punch them in, give me decimal answers. Although B kind of comes out nice. So the pi's cancel on this one. So in my calculator, I just do 5 times 180, and I divide that by 11. The sound of calculator keys is soothing. What do you got?
80.8.
Yeah. I got it. Make sure you put your degree symbol on it. Now this one isn't too bad because the pi's of course cancel, so punching in negative 4.2 times 180 isn't so bad. It comes out kind of nice. Yeah. Got it. Now don't let this intimidate you or throw you off your game because it doesn't have a pi on it. Remember, pi is just a decimal. So punch this in your calculator and hit divided by pi. Punch it in. I hear it, negative 32 point. Got it, agree. Any questions on that? Okay. All right. Last thing I have for you that might actually be new before we do a little geometry practice problems at the end here. So, focus, my friends. Hang in there. This is all calculator stuff again. I just got to show you where it's at and why we're doing it. The notation, obviously. I'm going to try not to complain about Texas insurance too much, but I probably will. Focus, people, focus. Quiet listening. Here we go. So if you take a look at this, it says use your angle conversions of your calculator, blah, 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 to convert it to decimal degree form. So these little symbols, Clearly that's a degree symbol, you all know that. One tick mark, this one means minutes, the double means seconds. These are in what we call degrees, minutes, seconds, answers. Now you're like, why is this a thing? Is this for real math? And it is. A lot of times it's used in navigation, like longitude and latitude, especially like the Navy when they're doing navigation, they measure the angles, degrees, minutes, seconds. All you have to know is where to find this stuff in your calculator and how to punch it in. Now, on your calculator, let me pull mine up. It doesn't matter what form you're in, meaning your mode. Mine's in radians. You can put it in degrees, but it's not going to matter because I'm going to force the numbers to be in degrees. So this is good. You haven't used it. Look in your apps. Right above apps it says angle. So you're going to hit second apps. So second apps. Now here's my Texas Instruments complaint, because there's always many. Clearly you have degree. Number 2 is the minutes. Do you see seconds in there? Why would we put seconds in there? That would just be too easy. Okay, so here's where seconds is. People, Grayson, I need you quiet and listening. You cannot come up to me during a quiz or test and ask me where to find this. I'm not going to help you. It's what I'm testing you on. Now, seconds, just to make it inconvenient, is above the plus sign. To access seconds, you have to hit alpha plus. Okay, well that's really convenient. So here's what you're going to do. We're going to type these in. I'm going to type in 245. I'm going to get into that apps menu, second apps. I'm going to put the degree symbol on. That's why it doesn't matter. Even though my mode's in radians, me putting the degree symbol on is forcing it into degrees. And then 10, second apps, and then number 2 for minutes. Now when I hit enter on it, you can hit enter, it's going to give you a decimal answer. It's converting that minute part just into a straight decimal. So I'm going to put my answer as 245.167 degrees. Okay, so when you type this one in, because you do have the second, so pull up the calculator, -408, hit your second apps, put on your degree symbol. Of course, I gotta look, I already forgot the minutes here. How many is it? 16. Second apps. Number 2. And then it seems like it'd be logical to have the seconds in there also, but 25 alpha plus for the seconds. So that is the same as -408.274, if we're gonna round it, 0.274 degrees. Now, one little glitch you might come across. So notice on A, I didn't have seconds, and I didn't waste the time of typing in 0 seconds. It wouldn't have made a difference. It would have been fine if I put 0 seconds. Yeah, because this might happen to you on the homework. If you don't have minutes, and you just try to type in degrees and seconds, it's going to give you like some sort of syntax error message. It's going to get angry. So if you're skipping the minutes part, you've got to put 0 in to hold the place. So if you get any sort of angry syntax error message, it's because you're missing the middle part and you don't have a 0 placeholder in there for it. So use that if you get some sort of problem. So you might need to, in case you might forget, jot down on your notes where to find these functions. Second apps, alpha plus. Because you're going to have to be able, I don't think it's super intuitive where to find these on your calculator. You have to know what menus to get into. So second apps, alpha plus, and you can see there's a little screenshot on your notes for you too. Okay, so use the angle of your calculator, same spiel, here we go. Plug your calculator, type in that -115.8. I'm going to hit second apps. Now this time I'm going to do number 4. That means that little triangle means convert degree, minute, second. I'm not going to write the 0 seconds clearly. You can, I don't care. But I'm just going to put -115 degrees, 48 minutes. Don't type in the next one yet. It's not in degrees. You're in what?
Radian.
Radians. So you have to first multiply it by 180 over 5. So first you gotta kick this one into degrees, a little tricky there for you. So punch that in, you get about 45.063. Now here's the deal. I'll have some poor kid do that and they circle it and they're like, I'm done. And I'm like, wait a minute, is this degrees, minutes, seconds? No, you have to pull up your calculator now and have it do it for you. So 45.063 second apps and number 4. So 45 degrees, 3 minutes, 46.8 seconds. 45 degrees, 3 minutes. I already forgot the seconds.
46.8.
Thanks. 46.8. There we go. So just be on the lookout for that. They might get fancy and give it to you in radians and you first need to convert it. All right, last 2 things we got to do, easy things. You should know from geometry. This is going to be fun. I can already sense it. Complementary angles add up to what? 90, I heard it. Somebody in another class told me 60. I almost had a mini stroke, but it's okay, all right. Supplements add up to? Now, and I'm going to put on here too, of course, that's the degrees. You might be in radians. 90 is pi over 2, of course. 180 is pi in radians. Because they might give you the angles in radians, so they're going to want the answers in radians. All right, let's do these last 2 and call it a day. Complement, supplement. I don't like the 129 for complement. Why am I already angry with the 129? It's already over what? 90. So we don't have one. We don't want to use a negative angle. Now, supplement. How much more do you need to get to 180? 51. Or of course, if you need a little calculator work, you're just subtracting them to find out how much more you need. Now, I'm going to do the same thing over here, but we're in radians. I want the answer in radians, okay? So, radians, complements, they add to 90. So I'm going to take 90, but the radians form, and I'm going to deduct my angle to see how much more I would need. Now, if you're not great with fractions, do 1/half minus 1/6 in your calculator. Or of course, 1/2 is 3/6. We should kind of maybe know that. 3/6 minus 1/6, 2/6. 2/6 reduced 1/3. Now every year I have some kid ask me, well, can I put pi over 6, can I convert to degrees, figure out the complement in degrees, and then convert it back to radians? And I'm like, well, sure, but that sure seems really time consuming versus just working with our fractions. Supplements should add to 180, which is pi in radians. So I'm just going to deduct my angle to see how much more I need. And we sure shouldn't need a calculator for this. What's 1 minus 1/6? 5/6. Got it. Okay. So the most time-consuming part of your homework today will be the sketching of the angles clearly, but then the rest of it is pretty light work, pretty calculator-oriented, so to say.